Hello everyone, welcome back to today's class. This is the fourth lecture for the chapter electricity. In this we will be studying factors on which the resistance of a conductor depends. Okay, so let us begin. We have made a circuit diagram. We have a circuit. Here we have battery, ammeter, key and a nichrome wire of length L and area of cross section A. Okay. First we note that the resistance of the wire is R. Now what we do is maintaining the same thickness of the wire, keeping the thickness same, we increase the length of the wire. Okay. So say we take double the length of the wire, 2L. So we increase the length of the wire. When we increase the length of the wire, we note that the resistance also increases. Okay, in the first case. Now in the second case, what we do is keeping the length same, we increase the area of cross section. Increase the cross sectional area. That is, we take a thick wire. Okay, so when we take a thick wire, we increase the area of cross section. We note that the resistance decreases. Okay, in the third case, we replace the wire of same length and same area, L and A, same length and same area, but now we take a copper wire. This is the first case, this is the second case, and in third case we take a copper wire. Okay, so we take a copper wire. So in this case we note that again the resistance changes. Okay, so in all the three cases, even if we change the length, we change the area of cross section, or we take another nature, some different nature of wire, we change the nature of the material. In all the three cases, we note that the resistance of the wire changes. This means the resistance of the wire is dependable on certain factors. So what are the factors on which the resistance depend? So in तीनों cases से हमें ये पता चल रहा है कि जो resistance है वो लेंथ ऑफ द वायर पे डिपेंड करता है. ठीक है, अगर हमने वायर की लेंथ कम ज्यादा कर दी तो रेजिस्टेंस भी चेंज हो जाएगा. सेकेंड, वो डिपेंड करता है ऑन एरिया ऑफ क्रॉस सेक्शन. अगर हमने एरिया ऑफ क्रॉस सेक्शन वेरी कर दिया, चेंज कर दिया, तो रेजिस्टेंस विल आल्सो चेंज. एंड थर्ड, इट डिपेंड्स ऑन द नेचर ऑफ द मटेरियल, कि हमने कौन से टाइप का मटेरियल, कौन से टाइप का वायर यूज किया है. सो द रेजिस्टेंस डिपेंड्स अपॉन थ्री फैक्टर्स. ओके, so from the activity we conclude that resistance is directly proportional to the length, since if length increases, resistance also increases. The resistance is inversely proportional to the area of cross section, because if the resistance increases, the area decreases. So it is inversely proportional to the area of cross section. First, second. Third, the resistance depends on the nature of material. Third. And fourth, there is one more thing, which is the temperature. The resistance also depends on the temperature. Okay. So these are the four factors on which the resistance of a wire depends. Now, we know that resistance is directly proportional to length and the resistance is inversely proportional to area of cross section. When we combine these both, L upon A, proportionality का साइन हटाएंगे तो equals to के साथ constant. Here the constant is this. This is the resistivity. The constant is the resistivity, and this letter is known as rho. This letter is known as rho, and this is resistivity. ठीक है, ये क्या है? resistivity है, और resistivity को denote किससे करते हैं? by letter rho. Okay, so now what is resistivity? So resistivity is the property of a material. Okay, so resistivity हर एक मटेरियल की अपने नेचर के हिसाब से एक फिक्स्ड प्रॉपर्टी है. ओके, तो हर एक मटेरियल कुछ रेजिस्टेंस ऑफर करता है, ठीक है, कुछ रेजिस्टिविटी ऑफर करता है, जो हर मटेरियल की अपनी फिक्स्ड होती है, और ये एक इनहेरेंट प्रॉपर्टी है फॉर एवरी मटेरियल. ठीक है, ये हर मटेरियल की अपनी फिक्स्ड होती है. ओके, finding the SI unit for resistivity, RA upon L equals to rho. SI unit for resistance is ohm. For area it is meter square, and for length it is meter. So we get the SI unit for resistivity as ohm meter. Getting the actual definition for resistivity. What is resistivity? The actual definition. So resistivity, it is the resistance offered by a conductor of unit length and unit area of cross section. That means कि अगर हम एक कंडक्टर ले, ओके, विच इज ऑफ यूनिट लेंथ, जिसकी लेंथ यूनिट हो, मीन्स 1 मीटर, एंड जिसका एरिया भी क्या हो, 1 मीटर स्क्वायर. यूनिट लेंथ एंड यूनिट एरिया. तो वो कंडक्टर जितना रेजिस्टेंस ऑफर करेगा, जितना ऑब्स्ट्रक्शन इन फ्लो ऑफ करंट ऑफर करेगा, दैट इज नोन एज रेजिस्टिविटी. सो दिस इज द एक्चुअल डेफिनेशन फॉर रेजिस्टिविटी. ओके, now some substances like metals and alloys, they have a low resistivity, that is their resistivity is in the range 10 to the power 8 to 10 to the power minus 8 to 10 to the power minus 6 ohm meter, while the insulators have larger resistivity ranging in 10 to the power 12 to 10 to the power 15 ohm meter. Okay, alloys usually have a high resistivity as compared to their constituent metals. For example, an alloy of copper will have higher resistivity as compared to that of the resistivity of copper. Copper की resistivity से ज़्यादा उसके alloy की resistivity होती है. ठीक है, so alloys have a higher resistivity as compared to their constituent metals. ठीक है, so अब इसकी वजह से क्या होता है कि the alloys do not oxidize easily, means do not burn easily. They do not burn easily. So this is the reason कि alloys are used for making electrical heating appliances. क्यों यूज करते हैं alloys? क्योंकि उनकी जो resistivity है वो काफी high होती है, जिसकी वजह से they do not burn easily or they do not oxidize easily even at higher temperatures. So this is the reason that they are used to make electrical heating appliances. So this is all about the factors affecting the resistance of a conductor. Okay. Now in next lecture we will be studying about combination of resistors.